You've heard about AI, right? ChatGPT, maybe GitHub Copilot. They're really impressive, no doubt. But what if I told you the AI landscape is moving even faster than you might think? It's going beyond these single powerful models. We're seeing whole new systems emerge that can learn and actually work together. So today, we're doing a deep dive into this fascinating evolution. We'll unravel the differences between AI agents and these newer agentic AI systems. Our mission, to give you a crystal clear picture of what these terms mean, where they came from, what they do, and crucially, the challenges that are still out there. We're drawing on a pretty comprehensive academic paper for this. It really maps out this fast-changing field, giving us history and a peek at the future. Oh, let's unpack this.
Yeah, and it's important to remember AI isn't exactly brand new. We've had intelligent systems for, well, decades now. Think way back to the early classical agents. Systems like MyCIN for medical diagnosis, or Denendral that figured out molecular structures. And XCon helped configure computer systems. These were based on rules, symbolic reasoning. They worked by manipulating symbols and logic, like following really precise if-then instructions.
Right, like very complex flowcharts almost. So they were smart for their time, definitely capable in their niche, but maybe a bit rigid. Like if the rules changed, they couldn't just adapt on the fly.
Exactly. They were designed for a specific task and stayed within those strict boundaries.
And I remember things like Eliza and Perry back then, too, with the chatbots. Fun for a minute, maybe, but you quickly hit a wall. They weren't understanding, just matching patterns.
Precisely. And we also saw early multi-agent systems, very basic coordination like auction systems for supply chains, or even just the scripted bad guys in old video games.
Yeah, the NPCs walking their little paths.
Right. The real limitation there was, well, limited autonomy, and they couldn't really adapt well if the environment changed suddenly. They performed their programmed tasks, but learning, adjusting, true complex interaction, that wasn't really there, which really set the stage for what came next.
And wow, what a next step. November 2022, for so many people, that was the moment. ChatGPT gets released, and suddenly it felt like AI just exploded globally. Investment, research, everyone was talking about it, using it.
Absolutely. ChatGPT's success really pushed generative agents into the mainstream. These are the systems, usually based on large language models, or LLMs, designed to create new stuff. Text, images, code, all from a user's prompt. You know the names. GitHub Copilot, Jasper, Midjourney. They fundamentally shifted how we interact with AI.
They're incredibly powerful tools. But for listeners using ChatGPT or similar tools daily, what's the key thing about how they work? How does that underlying design shape the interaction, especially compared to these newer agent concepts?
Well, the key thing is their reactivity. Generative models are purely input-driven. They generate something when you ask. They don't really have an internal state or memory that persists, or their own goals they're trying to follow. They're fundamentally stateless.
Stateless.
Yeah.
So like hitting refresh every time, unless you specifically remind it what you talked about before.
Pretty much, yeah.
Yeah.
You ask a question, then another. It doesn't inherently remember the first conversation unless you build that context into the new prompt. It's not planning steps ahead or managing a workflow on its own.
So like a brilliant assistant, you have to brief every single time, but they are getting more versatile, multimodal now, right? Images, code.
Oh, definitely. Models like GPT-4, Polym, BLI-P2, they can handle diverse outputs. Text, images, code, audio, you name it. But even with all that core prompt dependency and statelessness remain. They don't have those built-in feedback loops or the ability for complex multi-step planning on their own. And that's where things start to get really interesting.
Okay, so this leads us to AI agents. Now, it sounds like these generative tools are already doing amazing things, but are they limited by just the info baked into the model? Can they reach beyond that? What's the next level?
That's a really important distinction. See, AI agents aren't just the model itself. They're instantiated operational instances. Think of them more like active systems. They're designed to interface with users or maybe other systems to actually achieve goals. They have a structure, a defined, though bounded autonomy, and they stick to a task. They're not just reacting, they're working towards something specific.
Okay, so they have a purpose, a mission, and they're more proactive about it.
Mm-hmm.
What really defines them as an agent? What are the core characteristics?
Right. There are three key things. First, autonomy. Once you set them going, they operate with minimal human input needed. Second, task specificity. They're usually built for quite narrow, well-defined jobs, like fetching a current stock price or booking a meeting, not general-purpose chatting. And third, reactivity. They can respond dynamically to changes they detect. So think of them as highly specialized smart tools. They know their job and how to do it.
Makes sense, like a very focused worker bee maybe,
Yeah.
or that specialized financial assistant just tracking investments. But what's under the hood? Are they still using those big LLMs we talked about?
Yes, absolutely. LMs like GPT-4, PaLM, Claude, they often function as the cognitive engine for these agents. The LM interprets the goal, figures out a plan, picks strategies, manages the steps involved. You see this in systems like AutoGPT or maybe AGI, or GPT-4 is doing both the planning and the executing. It breaks down the big goal and acts on the pieces.
Okay, but what if the LLM doesn't know something needed for the task? Like, if the agent needs today's news or a specific file, can they go beyond their training data?
Yes. That's where tool-augmented AI agents are key. This is a really big deal. They overcome LLM limits, like making stuff up, hallucinations, or just having outdated knowledge by integrating external tools and APIs. So if an agent realizes it needs something it doesn't know, like the current weather, it can generate a structured call, maybe JSON, maybe SQL.
Like, it knows how to ask another program for help.
Exactly. It routes that call to the right tool, gets the output back, and then parses that information back into its own context. This lets it figure out the next step, incorporating that new external info. A perfect example is when ChatGPT uses its web search tool to answer something outside its training data. It recognizes the gap and calls the tool autonomously.
That is incredibly powerful, opens up a lot of possibilities. But I guess it also brings up new questions, right? Like security.
Yeah.
What should an agent be allowed to connect to?
Absolutely. Tool use brings immense power, but also requires careful governance and security considerations.
So what other kinds of practical applications are we seeing for these AI agents right now? Where are they making a difference?
Oh, they're showing up in a lot of places. For automated research, think AutoGPT planning and executing a market analysis by searching the web and summarizing what it finds. In coding, something like GPT Engineer can take a high-level design and actually write and execute code locally to build software. For science, Paper QA can dig through academic databases to answer questions based on published research. And get this, there are agent-enabled drones that can autonomously inspect an orchard, spot diseased fruit or broken branches, and send real-time alerts. An autonomous orchard inspector.
Wow, that's incredibly specific and useful. What about in businesses or things we might use more directly?
Definitely. Customer support is a big one. Agents like Salesforce Einstein or Intercom Fin use LLMs plus APIs to answer questions, sort issues, find documents, much more than a simple chatbot. Personalization engines, Amazon, YouTube, Spotify use agents analyzing your behavior to give you tailored recommendations, and scheduling. Tools like X.AI or Reclaim AI can take a vague request like find time next week, check everyone's calendars via APIs, find the best slot, and book it, even handling conflicts.
Okay, this is a huge leap from just generating text or images. We've gone from reactive prompts to goal-driven tools that can interact with the world. But what happens when you get these agents to, well, to talk to each other? That's the bridge to agentic AI, isn't it?
Precisely. That's the next major conceptual shift. Agentic AI moves us from these individual specialized AI agents to collaborative distributed ecosystems. Instead of one smart tool, imagine a whole team of specialized agents working together on a larger goal. It's a real jump towards system-level intelligence. The whole becomes much, much greater than the sum of its parts.
A team, or like you said before, almost an organism of intelligence. That's a fascinating idea. So it's about harnessing collective smarts. What architecture makes that possible? What's different?
Well, you have an ensemble of specialized agents, not just one agent doing everything, but a team, maybe a summarizer agent, a data retrieval agent, a planning agent, each with a role. They need more advanced reasoning and planning, like task decomposition, breaking down big problems. Persistent memory is absolutely vital, so they have a shared context. And often there's an orchestration layer, maybe a meta agent. Think of it like a project manager or the virtual CEO in the chat dev system. It coordinates the others, manages who does what, handles conflicts.
So how do they actually coordinate? Is it like passing messages back and forth constantly?
It can be through messaging, yeah. Or using shared memory spaces where they can all read and write information, or just by exchanging outputs. This allows coordination without one central bottleneck all the time. And critically, they use reflection and memory. They can look back at past actions, learn from them, and adjust their strategies over time, like a team refining its tactics during a game.
This sounds like science fiction becoming reality. Can you give us some concrete examples, something that really shows off this collaborative power in action?
Okay, think about that robotic harvesting example again. But now, imagine a swarm of drones mapping, identifying disease, and then coordinating directly with picker robots and transport robots, all managed by an orchestrator, maybe using a shared digital map and task list in memory. That's agentic AI, or in a hospital ICU. You could have a diagnostic agent analyzing vitals, a history agent pulling relevant patient records, and a treatment planning agent suggesting interventions. They all synchronize through shared memory, maybe flag interactions or contradictions, helping the clinical team.
Wow, that's healthcare potential right there.
Yeah.
Any other areas?
Sure. Automated grant writing is a good one. Imagine a system with retriever agents finding similar successful proposals, alignment agents checking against the grant rules, formatting agents putting it all together nicely, all supervised by an orchestrator, using persistent memory to keep track of the draft and sources. Or even smart homes, multiple agents managing weather forecasts, your schedule, home energy use, security systems working together. The weather agent sees a shitwave coming, tells the energy agent to pre-cool the house using solar before peak electricity rates hit, maybe tells the scheduling agent to delay running the dishwasher, that kind of synergy.
Okay, so this distinction between a single AI agent and a whole agentic AI system,
Yeah.
why does it really matter to us, to the listener? What's the key takeaway here?
It fundamentally boils down to designing the right tool for the job. It's about precision. Understanding the difference means you can build appropriately. You use modular AI agents for specific, often tool-assisted tasks. You architect agentic AI systems when you need complex, orchestrated operations involving multiple steps and likely multiple specialized skills. It's like knowing when you need a screwdriver versus needing an entire assembly line.
I bet it changes how you even measure if they're working well or if they're safe.
Absolutely. The evaluation metrics are different. Safety protocols need to account for interactions. Resource needs are vastly different. And honestly, it helps development efficiency hugely. It stops people from over-engineering simple problems with complex agent teams, or maybe worse, trying to solve really complex coordination problems with a single overloaded agent. Getting this distinction right saves time, resources, and probably a lot of headaches for developers. Avoids fitting square pegs in round holes, basically.
Right. Okay. The potential is clearly massive. But like any powerful tech, there have to be challenges. Let's start with the individual AI agents. What are the main hurdles they face?
Well, a really fundamental one for individual agents is the lack of true causal understanding. They're great at spotting correlations, seeing that A often happens with B, but understanding why, that A causes B, that's much harder for them. This limits their ability to make truly informed decisions or reason about what-if scenarios, counterfactuals that weren't in their training.
So they might see wet streets and umbrellas go together, but not grasp the rain causing both. And I assume they inherit problems from the LLMs powering them too.
Oh, yes, definitely. They inherit the LLM limitations. That includes hallucinations generating plausible but wrong information, high sensitivity to how you force the prompt, sometimes shallow reasoning that just mimics logic, plus the high computational cost, the knowledge cutoffs based on training data, and the risk of perpetuating biases present in that data. Another big one is planning over long sequences of steps and recovering if something goes wrong partway through. They can get stuck in loops or just fail completely if one subtask breaks.
Okay, and if those are the problems with one agent, what happens when you connect a whole bunch of them in an agentic system? Does it just make everything worse? It sounds like going from one tricky problem to a whole network of them. That must be a nightmare to debug.
It absolutely amplifies the challenges. You get amplified causality issues. Now you have complex interactions between agents, making it even harder to figure out cause and effect. You risk error cascades where one agent's mistake pollutes the whole system. Communication and coordination become major bottlenecks. How do you ensure they all understand the goal the same way? How do they communicate clearly, especially using natural language, which can be ambiguous? How do you manage conflicts if two agents need the same resource? Huge hurdles.
So getting them to cooperate effectively isn't guaranteed at all.
Not at all. And then there's emergent behavior. When multiple agents interact, you can get results that nobody predicted, maybe even harmful ones. The system becomes less predictable, harder to control, scalability is tough, and debugging. Like you said, finding the root cause of a failure in a complex multi-agent system where each agent might be a bit of a black box, incredibly difficult. Just adding more agents doesn't automatically make the system smarter if they aren't orchestrated perfectly. And then you have the ethical and governance issues. Who's responsible for an outcome produced by 10 agents? Bias can get amplified across the network. Security risks increase with more connections. And honestly, the foundations are still being built. We lack standardized ways to build these systems. Robust causal reasoning isn't quite there yet. It's still a bit fragmented.
Well, okay. That's a sobering list of challenges.
Hmm.
But researchers are working on this, right? What are some of the promising solutions helping to pave the way forward?
Yes, definitely. One key technique is retrieval augmented generation, RG. We mentioned it briefly. It helps fight hallucinations and outdated knowledge by letting the agent pull in real time external information to ground its responses. For agentic AI, RI can act as a sort of shared truth source, making sure all agents are working from the same current facts. Another really important approach is using iterative loops like reason, act, observe. Frameworks like React embody this. The agent thinks, decides on an action, maybe calling a tool, performs it, observes the result, and then reasons about the next step. It makes them more deliberate, more context aware.
That sounds like it builds in a kind of learning cycle, helping them adjust as they go. What about memory, especially for teams of agents needing that shared context you mentioned?
Yeah, advanced memory architectures are absolutely critical. We're talking about different kinds, like episodic memory for specific past events, semantic memory for general knowledge, and vector memory for understanding relationships between concepts. This allows agents to recall past actions, store learned knowledge effectively, and retrieve relevant information for complex planning. It's essential for continuity in long tasks and for the whole system to maintain coherence. Robust orchestration frameworks are also key software that helps manage the roles, the communication flow, the task assignments between agents, and programmatic prompts, basically. Automating the creation of really precise instructions for each agent helps ensure consistency.
And how do we peek inside these complex systems to understand failures or just build trust?
And that's where monitoring, auditing, and explainability come in. We need much better logging to track what each agent did and why. We need explainability tools that can help trace the reasoning path that led to a particular outcome. This is crucial not just for debugging, but for compliance, for safety, and simply for building human trust in these increasingly autonomous systems.
It feels like a lot of this is about making the systems more robust, more transparent, maybe more deliberate. Is there anything truly revolutionary on the horizon that could fundamentally change things?
Well, one really exciting, potentially game-changing idea is this concept of absolute zero. It stands for Reinforced Self-Play Reasoning with Zero Data, or AZR. The core idea is that agents could learn by essentially generating their own problems, trying to solve them, and then validating the solutions themselves, maybe using verifiable methods like running code it generated. This could potentially remove the dependency on massive human-curated data sets for training. Agents could learn more autonomously, adapt faster to new situations, especially where data is scarce. It could be truly transformative for how AI learns and reasons.
Wow. Self-generating, self-solving problems. That's quite a vision. Okay, so we've really covered a lot of ground here. We've journeyed from those early rule-based AI systems through the generative AI boom to these sophisticated tool-using AI agents. And now we're seeing the dawn of truly collaborative agentic AI systems. This deep dive really highlights just how incredibly fast this field is moving.
It really is. And it's not just theory anymore. These systems are actively being developed and deployed, starting to make real impacts in industries from farming to medicine. The potential for more automation, for tackling really complex problems, it's immense.
So as we wrap up, here's something for you, the listener, to think about. As these AI systems gain more autonomy, as they start genuinely collaborating with each other, what new questions do that raise for you? Questions about intelligence itself, maybe, about responsibility, even creativity. What does it mean for, say, the future of work, when AI systems can truly talk amongst themselves and orchestrate complex projects, perhaps without much direct human input? Lots to ponder there.